far, every question you encountered had items that were unique. So either people, animals, books, whatever, letters in a word, they were unique. But what if you have some identical objects in the mix? What if you have things that are exactly the same? You would not be able to tell if you swapped them around. Okay? Then you have to do an extra little step here. What we need to do is we need to divide out the repetition, because we cannot tell them apart. So balloons, for example, red balloon, if you have a bunch of red balloons, if I had 3 red balloons here and I inflated them all to be exactly the same, would you be able to tell if I moved this one on the left over to the right and vice versa? Would you be able to say, oh, that's a different arrangement? You would not be able to tell, right? It's exactly the same thing. So when that happens, we just take extra steps for that. So arranging people would count as unique or distinguishable. No repetition there. So you don't have to worry about, because sometimes I tell students, oh, there's 5 students taking a picture, they're all wearing a red shirt. Or they are wearing a Sizzler shirt. And they're like, oh, that's repetition. It's like, no, the faces are all different, right? So don't fall for that. It's going to be very obvious. So in general, okay, this is the formula that deals with repetition. So n is the total number of objects that are present. A is the number of the first set of identical objects. In this case, it's a pattern I want you to observe. Sometimes all you need is 1 factorial there and that's it. But if there's another group of identical objects, you would take that number and put a factorial to it, and you would do that for as many instances as you encounter. Okay? So let's do a question here. Examples. How many ways can the letters in the word eyes be arranged? Okay? How many letters do you have? 1, 2, 3, 4. N is equal to 4. So noisy. 4 letters, right? But what do you notice? What is there a double of? There's 2 E's, right? So you've got 2 E's. Okay? They're identical. So how would you say, if I asked you how many ways can you arrange these letters, we used to just say 4 factorial, right? Up until today, you would just say it's 4, 3, 2, 1. But because of the 2 E's, you got to take that number and divide that out. Just like, I don't want to count that twice because it's not a different permutation. Okay? So the 2 E's are here. If you want to write down 2 E's, just to make it stand out, that's how you would do it. 4 factorial is 24. 2 factorial is just 2. So it's 12 ways. I just want you to know, like, a reason for this is, let's say you do eyes like this, and let's distinguish them. Let's put a 1 there and a 2 there. Right? Let's make a distinction between those 2 E's, because then we can track them. What if I flip them and put this E up front and the one that used to be up front further back? Okay? These are considered the same permutation / arrangement. That's why we divide out the 2 factorial, because we don't want to count that as 2 unique arrangements, okay? I believe in you, so can you try this one real quick? What's n? Any repeats? There's two c's, right? So this would be 6 factorial over 2 factorial. 6 factorial is 720 over 2. So there's 360 ways to arrange the letters in that. If there are no repeats, guys, don't bother dividing, right? You don't need to divide by anything. But if there are repeats, you got to make sure you account for that. One more, eyeballs. The province comes up with some weird words sometimes. Like they're super long. They've got like 3 E's, 4 L's. Like they are creative. Okay, so I'm starting small, but you will encounter all kinds of scenarios. You've got two E's there, right? You've got 2 L's. Help me out. Is there anything else? I think that's it. So how would you do this? You'd go 8 factorial as always. So if it was just a regular word, you would just take the letters and factorial it, right? But then you have to divide by 2 factorial times 2 factorial. Please be careful when you do this. 8 factorial, if memory serves me right, is this. 2 times 2 basically down in the denominator, so it's divided by 4. So it's 1,080 ways. Normally, the way I remember the province setting this up is you get 1 mark for the top number correctly, and then you might actually get half and half here, so it's a total of 2 marks usually for something that has repetition. Also a classic. Okay, so hold on, before I move on, I want you to highlight this box here. And add that to your study sheet. Perms checklist, permutations checklist. I want you to always check for, is there any restriction? Please cross out grouping and replace that with beside each other, or you can replace that with together, one or the other. And the last thing I always want you to check is, are there identical objects? Are there objects that are exactly the same that we cannot distinguish? So if a question says there are 5 red balloons and they all have a different smiley face on or emoji on them, like if there's something that distinguishes them, it's no longer identical. It's just they're each kind of dealt with separately. I'm going to say this. I don't know how far you got, but I'm going to tell you to go back to pages 20 to 23. Okay, so your homework. And if you want to practice this, this has together. You can do it together as well. But this one has examples where things are together and all kinds of different scenarios, guys. It's very good practice. I put it in here for a reason, as well as, I'm just going to say all the way to 27. I will say that most of these questions don't take very long, okay? So you have identicals in there. You've got Mississippi, all those fun ones.